Example 3. Solve the inequality 5x plus 3 is greater than or equal to 2x squared. Okay, so first thing to notice, highest power of x is 2. Okay, so this is going to be quadratic. You've got an inequality symbol, the greater than or equal to. So this is a quadratic inequality. Okay, so first thing we need to do is make sure our inequality is in the format ax squared plus bx plus c. And that's what's going to go right here. Okay, so we need one side to be 0. So basically we're going to move this 2x squared over. That's going to be the easiest thing to do. And again, I am just subtracting, so there is no need to switch the inequality symbol. Okay, so we're going to get negative 2x squared plus 5x plus 3 is greater than or equal to 0. Okay, so that's what's going to go in this rewrite inequality box. And going forward, this is how I want to think about the inequality. Okay. All right, so we are going to make a rough sketch of the parabola like we did in example 2. Okay, again, you need two things. Okay, first thing, does the parabola open up or down? Okay, and then the second thing you need to know are the x-intercepts. Okay, that's it. Okay, all right, so when we look at this inequality, okay, so here we are. Okay, remember, this becomes, your f of x becomes the non-zero side. Okay, so the f of x, your function is going to be negative 2x squared plus 5x plus 3. That's the parabola you're dealing with and ultimately going to graph or make the rough sketch of. Okay, the a value here is negative 2. The b value is 5 and the c value is 3. Okay, and so since that a value is negative, okay, we have a parabola that's going to open downward. Okay. All right, so now we just need the x-intercepts and then we can make our sketch. Okay, so for the x-intercepts, I need to set y equal to 0. Okay, so again, over here, this is your y. Okay, so we're going to have 0 equals negative 2x squared plus 5x plus 3. Okay, we now have a quadratic equation. So we have an equal sign. So you either factor or use the quadratic formula. Okay. That negative sign, that negative 2 kind of makes this tricky to factor. So I'm going to go ahead and use the quadratic formula here. But you could try to factor if you wanted to. One side is 0, so I'm good to go. Okay, I'm going to plug into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. We already know the a, b, and the c. Okay. So let's plug in. So we're going to get negative b, so negative 5 plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so we need to go ahead and simplify this. Okay, so let's see. We're going to get negative 5 plus or minus underneath the square root. What do we have? We have 5 squared is 25. Minus times minus is going to give us plus 8. 4 times 2 is 8 times 3 is 24. So underneath we have 49. Okay, and in the bottom we have negative 4. Okay, so this is going to be negative 5 plus or minus the square root of 49 is 7 over negative 4. Okay, I'll go over here since I'm running out of room. Okay, and I'll write out my actual x-intercepts here. Remember, because of that plus or minus, you're getting two x-intercepts here. The first one is going to be from picking the positive, so negative 5 plus 7 divided by negative 4. This is going to be, let me see here, this is going to be positive 2 over negative 4. So you're going to get negative 1/2 or negative 0.5. That's one x-intercept. Okay. And then the other one comes from choosing the minus sign in the middle. So we're going to get negative 5 minus 7 over negative 4. So we're going to get, let me get rid of this page number so we don't confuse it. we're going to get negative 12 over negative 4. You get positive 3. Okay, so those are your two x-intercepts. Okay, all right, we are ready for a rough sketch. Okay, so your rough sketch over here. Again, I'm only going to draw the x-axis here. Okay, I'm going to put my x-intercepts on here in order from left to right. Okay, I'm going to have negative 0.5, which again is the same thing as negative 1/2. And then the other one is positive 3. Okay, we know from earlier that the parabola opens downward. Okay, so here are my intercepts, my x-intercepts, and we're opening downward. Again, it's not helpful to know where the vertex is specifically, so we don't have to worry about that. Okay, so there's our rough sketch. Okay, so let's go back to our inequality to figure out if we need to be looking above the x-axis or below. All right, so here's our inequality that we're working with. Okay, remember this is our f of x. Okay, our f of x is this part. Okay, so this is asking us, we need to figure out where f of x is greater than or equal to 0. Okay, that's the same thing as y is greater than or equal to 0. So we want y values that are bigger than 0 or equal to. Okay, so we want positive y values, so we need to be looking above the x-axis. Okay, so we're going to want this part of the parabola. Okay, so that's the part we're interested in. So now you can go ahead and write down your solution set. Okay, so remember, we're going to write down the x values over which this part of the parabola is happening. Okay, you have to use interval notation because you need to catch all the decimals in between. Okay, so go from left to right. This part of the parabola is occurring between the x values, negative 0.5 or negative 1/2. If you want to use the fraction, that's fine, and positive 3. Okay, so we're going to get this. Okay, last step, do I include the endpoints? Well, I have greater than or equal to, so the y values can actually equal 0. Okay, so remember, this is actually the 0.30. This is negative 0.5 with a y coordinate of 0. Okay, you can actually have y values of 0, so you do want to include your x-intercepts there. So we will put brackets. Okay, and that is our solution set. So remember, any x value between negative 0.5 or negative 1/2 and positive 3, okay, including those endpoints, if you plug that x value into the original inequality, you will get a true statement.